Uncertainty is a fact of life, but there are some things we should never be uncertain about, like whether today we'll have access to clean water. But in Indonesia, as climate change and worsening natural disasters threaten water security, more and more people might be asking that question every day. Indonesia's water supply system is especially susceptible to natural hazards. Water sources are degraded or overexploited, especially in fast-growing urban areas. Indonesia's water sector, suffering from fragmentation and insufficient funding, is struggling to keep up with urban growth. In 2018, only 25% of the total population and 30% of urban Indonesians were connected to piped water. And since most water utilities aren't prepared for natural disasters or other disruptions, people who do have piped water might lose service in an emergency. Past disasters have disrupted water services for weeks, reduced water quality, or destroyed pipes and treatment plants. When a landslide struck Magelang City in 2008, the city's damaged water pipes leaked 70 liters of water per second for 10 hours straight, or the volume of an Olympic swimming pool. The loss was equivalent to the daily water usage of 10,000 households. We don't know exactly what's down the road for Indonesia, but with the water security of hundreds of millions of people at risk, we can't let uncertainty stop us from acting. Water service providers need to take steps today to proactively manage climate and disaster uncertainty and make water supply systems more resilient to future threats. But the data, methods, and materials we've used to design and construct water infrastructure in the past won't work anymore. We need new ways of building and managing water systems and a new mindset of risk-based decision-making. What does that look like? Imagine we're a local water supplier. We provide service to a growing urban area. There's a reservoir nearby, and water gets to the city through a combination of surface channels and underground pipes. It's cleaned in a water treatment plant, then stored in above-ground steel water towers. Sometimes the area suffers from heavy rains, and there's a volcano 100 miles away. We know that natural disasters might threaten some parts of our system, but we're uncertain which parts are at risk or how big those risks are. We can reduce our uncertainty by making risk assessments a routine part of our business continuity planning. We'll learn what parts of our system and infrastructure are vulnerable and how best to protect them. Risk assessments have 3 main steps: identifying hazards, analyzing risks, and evaluating resilience options. The first step is to identify hazards, whether they are natural hazards, like earthquakes and floods, or non-natural hazards, like power outages and pollution. If engineers understand climate and disaster risk, they can make informed design decisions and develop smart plans for future expansion. In this case, we may find that the volcano is too far away to do much damage, but the local area is susceptible to flooding, landslides, and earthquakes. The next step is to analyze the risks posed by those hazards using tools like disaster risk maps. Maybe we find that the water towers are in the path of potential landslides. Flooding could damage the equipment at the treatment plant, and an earthquake could crack the reservoir's dam and the underground pipes. The final step is to work with stakeholders, like local governments, to evaluate how to prioritize investments in resilience. Based on factors like cost and geography, we might decide to reinforce the water towers and the dam and install new pipes made from a more flexible material. There's no one-size-fits-all solution for resilience. Every project and every stakeholder is unique. Still, there are a few basic engineering principles that every water provider can follow to increase resilience. Engineers can design infrastructure with stronger materials like concrete and steel, rather than wood or aluminum. planners can elevate essential equipment above flood level and select sites carefully to ensure they're building on a firm foundation and avoiding high-risk areas. We can make systems stronger if we build in redundancy, invest in routine maintenance, retrofit older infrastructure, and design new components to withstand larger and more frequent hazards. For instance, when Mount Merapi erupted in 2010, volcanic ash entered the raw water in the supply system in Bantul district, affecting the performance of water treatment facilities. But in Magelang City, the local water provider had recognized the risk and built reinforced concrete structures around the city's water sources to protect them from volcanic dust. The structures kept all 5 of the city's water sources clean. A new technical report from the World Bank highlights solutions like these, along with the technical aspects of planning and managing a resilient urban water supply. It suggests best practice planning procedures and concrete engineering measures for more resilient water systems, sharing the knowledge practitioners need in order to recognize risk and know how to mitigate it. But just as importantly, practitioners must be able to act. Governments can help by providing the basics, funding mechanisms, strong regulations, and incentives for good practices. That's why the World Bank Technical Report also provides guidance for government officials so that countries like Indonesia can increase resilience while saving costs. Disasters can rarely be prevented, and there's always some residual risk. So water suppliers should plan how they'll respond quickly in an emergency and work with governments and emergency management services to make sure the community can recover swiftly. The future may be uncertain, but if we plan ahead, we'll be able to reduce the risks of the hazards we can mitigate and prepare for the ones we can't. So that despite future disasters and a changing climate, Indonesians can be certain of a safe and steady supply of water.